Hey, Sec 230 students. So this is the second attempt to do the muddy points for chapters 2 and 3. First one, the video didn't record. So I've been having lots of technical issues, so I'm sorry for these getting out to you so late. But let's do it again. So with chapters 2 and 3, so let's start with chapter 2, which is our frequency distributions. So when it comes to frequency distributions, basically there's the two types. There's going to be either tables or graphs. And one of the things that I would suggest is that you get comfortable going back and forth between tables and graphs, but also be able to take any random set of numbers and convert it into a table and a graph. So that's what I want to show you first. That was some of the things that came up, people struggling just a little bit with, like, let's say calculating a mean from a histogram, or figuring out what n is, the total number of people. So let me show you how to do that by just kind of showing you how to go back and forth. So the first thing I'm going to do is I'm going to show you a random assortment of scores. Okay, so we've got these scores, let's say. Okay, so those are our scores. Oops, I'm sorry, I didn't mean to show it to you. Okay, so these are the random set of scores we're given. So we've got, looks like 10 people here. Those 10 people each had a different score, so they vary on whatever we're measuring here. So these are all technically X's. So an X is an individual score. So technically, maybe this first one would be an X sub 1, the second one would be an X sub 2, and so on. But just, these are all X's from 10 different people. So if we want to create a frequency table, what we want are two columns. The first column is our X column. Okay, so with the X column, what we're going to do is list out all the scores that we have. And actually the best way to do this is to go ahead and find the highest score and the lowest score. So when I look through this data, I see that an 8 is my highest score and a 2 is my lowest score. So I'm going to list every score between 8 and 2. So 8, 7, 6, 5, 4, 3, 2. So those are all my X's. Now what I'm going to do is I'm going to create a second column where I'm going to count how many people have those scores. And this is what we refer to as our frequency column. Frequency is just a statistics word for count, how many people. So I'm going to count how many people have 8s. And so as I do it, I cross off the numbers. So there's one 8 and there's a second 8. So I have two 8s. 7s. I don't see any 7s. I'm going to put a 0. It's a 0 frequency. Nobody had the score of 7. I include the 7 just partly because it's between my highest and lowest score. Then I go count the 6s. I see one, just one, 6. Count the 5s. There's a 1, 2 5s. Count the 4s. 1, 2. Count the 3s. 1, 2. And count the 2s. I see 1, 2. Okay. So basically what I've just done is taken the random set of numbers and converted it into a frequency table. This frequency table mainly just helps us organize and summarize the data. It just gives us a sense of where people scored sort of at a glance. Whereas when we look at it just as raw scores, if somebody was saying, oh, how do people, were a lot of people scoring in the middle, middle of the scores, I'd not be really clear here. But here I can go, oh, okay, the middle here, yeah, there's a few people scoring around the middle. Or, do you tend to have more numbers towards the bottom, lower scores, or more scores towards the top? I can be looking at these frequencies for the higher scores and frequencies for the lower scores to interpret it. So this helps organize and summarize our data. So that's taking our raw data, converting it to a frequency table. I can also take this raw data and convert it to a histogram. What I would do to do that is I would first turn it into a table, because once I have the table, I can create easily a histogram or a frequency polygon for it. So for that, I might have something like this. And what I'll do is I'll have the different scores down here on the x-axis. So on the x-axis, I'm going to list all my scores, 2, 3, 4, 5, 6, 7, 8. Okay, and then I can put a 9 if I want and a 1 there. And so those are x's. And then on the y-axis, I'll do 1, 2, 3. Okay, so if I want to do this, I'm going to start with my lowest score here. The 2 has a frequency of 1. So there's my score of 2. And so I'm going to put a bar above that that goes up to the frequency of 1. And so I just tried to make this so that the frequency of 1 goes up to this spot here. So we'll do 1 here. That'll make it a little bit easier for us to see. Okay, so there are my bars. So there I've got a bar for 1. And then for the 3s, I see it goes up to 2. For the 4s, I see it goes up to 2 as well. For the 5s, also 2 as well. For the 6, it's a frequency of 1. For the 7, it's a frequency of 0. And then for an 8, a frequency of 1. So then what I can do if I want is to make this a little bit more visible. I can fill in the bar. And there is my histogram for this data. So this data is represented by this. This data is also represented by this. These two can, again, go back and forth. So what you want to be able to do is turn a table into a histogram, or if I gave you this, you should be able to turn it into this, because again, these x's go in their list on the left-hand side, and then the height of the bars tells you what the frequency is. The reason why you want to be able to do all this is because I could give you any of these 3 options here, and I could ask you to do some calculations. For instance, I could ask you to calculate the mean, the median, the mode. I could ask you to tell me what's the total number of people. I can do all those kind of things. So that's where this one is actually the easiest to do a lot of those calculations with. So for instance, if I wanted to know the n, what's the total number of people, I could just count the raw scores, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if it's in a frequency table or it's in a graph, I can count the frequencies. So I'm going to add down this column. 2 plus 1 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 1 is 10. That's my n of 10. Okay, so that would be something I might ask. And again, here, if I'm not sure how to do that with this, I just convert it to the frequency table, do that. But another thing you could do is just think of it as this has a frequency of 1, that has a frequency of 2, that has a frequency of 2, frequency of 2, frequency of 1, frequency of 0, frequency of 1. And then just add those up. 1 plus 2 plus 2 plus 2 plus 1 plus 1. And I missed something. Where did I go wrong? Oh, 8 has 2. So I make lots of mistakes. You're probably this whole time watching this video saying, nope, nope, wrong, wrong, wrong. Okay, so that's an 8 has a frequency of 2. Okay, so now it adds up. So 1 plus 2 plus 2 plus 2 plus 1 plus 2 matches this. Again, I could get that n of 10. Now it can be an uppercase n or lowercase n. It all just depends on whether I told you this data that you started with was a population or a sample. Population, it would be an uppercase n. Sample would be a lowercase n. So then what if I said, okay, what's the mean for this data? Well, to do that, we already have n. We want to think about what is our mean formula. So if I told you this is a population, it's sum of x over n. If I told you it was a sample, it would be sum of x over n as well. It's just lowercase and an m. Okay, so those are our formulas. So let's assume this is a population because we already have the uppercase n here. I have the n, so I know in terms of calculating my mean, I know that it's going to be divided by 10 because that's my n. But what I don't know is sum of x. So what sum of x is asking me to add up everybody's score, not to just add up the scores. So we don't add down this column this time because we don't just have 1 8. We have 2 8s. That's what that frequency tells us. We don't even have a 7. We have 0 7s. We have 1 6, but we have 2 5s and so on. So the strategy here is you multiply across. You create an x times f column. 8 times 2 is 16. 7 times 0 is 0. 6 times 1 is 6. 5 times 2 is 10. 4 times 2 is 8. 3 times 2 is 6. almost put 5, and 2 times 1 is 2. Gosh. Okay, so now I can add down that column. So if I do that, it's 16 plus 6 plus 10 plus 8 plus 6 plus 2. And I get 48. Okay, so I'm just going to double check my work here. So that's 20, 32, 40, 48. Yep. Okay, so my sum of x is 48. So my mean is going to be 48 over 10, or 4.8. On average, people had an average score of 4.8. Now, if I had just given you the raw data, you could convert it to the table. You don't need to. All you have to do is add the scores. This set of scores, because it's kind of a small set of scores, it's not too hard. You could just add 5 plus 6 plus 8 plus 2 plus 4 plus 3 plus 3 plus 4 plus 8 plus 5, and you get 48. And then you just count them. There are 10 of them. 48 over 10 gives you 4.8. So again, just be ready to work back and forth between these. The other thing I'll just say with this table is that we can also do percentages and proportions. And so let me recreate that down here. So if I have my scores 8, 7, 6, 5, 4, 3, 2, 2, 0, 1, 2, 2, 2, 1. Okay, so to calculate a proportion, it's the frequency for that score divided by the n, or it can be uppercase N or lowercase n. So again, I know my n is 10. So now I just take the frequency for the 8 and I divide that. Oops, sorry, not the 8. I want to put the 2. We'll go 2 divided by 10. So you could stop there. 2 over 10 actually is an answer for this. You could also reduce that. It could be 1/5. Either of those you could enter into WebAssign. You could do on the test. It all works fine. You can also calculate it out and get 0.2. So 0.2 or 2/10 or 1/5, those would all count as the proportion of people who scored an 8. You can see we have 0 over 10 or 0.00 for 7s. We have 1 over 10 or 0.10. We have 2 over 10 for the 5s or 0.20. 2 over 10 for the 4s or 0.20. 2 over 10 for the 3s or 0.20, and 1 over 10 or 0.10 for the 2s. Okay. One thing you can always do is check your work here. This should add up to, 10/10 and 1.0. Okay, so one thing to remember, this is a proportion. So again, you can either answer a proportion as a fraction or as a decimal. So it'll be something less than, it'll be between 0 and 1, basically. And we can also combine them. And so if I said, okay, what proportion of people scored 6 or above, you can then just add the 2/10 plus 0/10 plus 1/10 gives us 3/10. And that could be an answer, 3/10. Or you can calculate it out and it would be 0.30. In other words, add 0.2 plus 0.0 plus 0.1. Okay, so that would be a way that we can do combinations. So the other thing is we can also turn it into a percentage. And the percentage is where you just take the proportion times 100. And so this would be 0.20 times 100 is 20%. 0% is for the 7. 10% scored a 6. 20% scored a 5. 20% scored a 4. 20% scored a 3. And 10% scored a 2. Okay, and again, that should add up to 100%. So that's another thing that you want to be comfortable to do, because this is something helpful that, I can say again, and be careful to what I ask for. So if I say what percentage of people scored a 4, go to the 4 row, go all the way across to the percentage, and your answer is a 20%. 20% scored a 4. What proportion scored a 4? Then you would look at the proportion column, and you could give me either 2/10, 1/5, or 0.20. All right. And again, you can combine. So again, we would have 30% scored a 6 or above. We could say 20 plus 10%, 30% scored a 2 or a 3. So there's all sorts of different ways we can answer this. The last thing that we can do also, so now we know how to calculate a mean. We know how to do the proportions and percentages. A couple other things. So if I ask you mean, median, and mode for a set of scores, any of these three ways, right? Set of scores, frequency table, or a frequency graph. Now we know how to do the mean. To do the mode's the simplest one. Create the frequency table. Look for the highest frequency. In this case, we would have to report 4 different modes. The mode would be 8, 5, 4, and 3. Because those all have the highest frequency, and in our case, the frequency of 2. So the mode would be 8, 5, 4, and 3. So you just look for the highest one. If one of these was a 3 frequency, that would be the highest frequency. Then whatever score that was, had that frequency, would be the mode. Okay, so that's how we did mode. And so we've got the mean, we've got the mode, and then for the median, the thing is, you can answer a median through here, but you kind of have to know what you're doing. So I'd be careful with that. What I would do instead is take whatever you're given and then put the set of scores, just list the scores out, because like on a test question, I'm not going to give you a big long list of scores or a big frequency table or graph. It's going to be a reasonable number. Just list them out in order. And then I would do it lowest to highest, because that just probably makes most sense to people. So, if I was given this, I have to put them in order. If I was given this, again, they're already in order, and I just have to count how many I have. So when I look at that table, or maybe it's easier to see this table here, I see that I have 1, 2. So I can list that out. And then I have 2 3s. So I list both 3s. I have 2 4s. I list both 4s. I have 2 5s. I list both 5s. I have 1 6, no 7s, and 2 8s. I can count to make sure I have all the scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks good. Now at this point, I know again that I have this n of 10. Because that my n is even, that means I need to find the 2 scores in the middle. So typically what helps to do is come in from the outside. And so at one at a time. So 1, 2, 3, 4. And then that leaves me 2 scores. Those are the 2 scores in the middle. Whatever those 2 scores, just add them and divide by 2. Essentially, we're taking the average of the 2. Okay, so we would get, for the median, 4 plus 5 over 2, or 4.5. And this one works out as a precise median because 4.5 is exactly in between those two. And you can see that there's 1, 2, 3, 4, 5 scores below 4.5 and 1, 2, 3, 4, 5 scores above 4.5. Okay, so that's how it works. If, again, isn't always going to be a precise median for our purposes. So we just do find the 2 middle scores and average them. So sometimes it won't perfectly split it into halves. So as an example, let's say we only had 9 scores here. So now we've got an odd number of scores. And let's say these were the scores. So we have the 2, 3, 3, 4, 4, 5, 5, 6, and 8. So now we have an n of 9. That's an odd number. So now I want to find the 1 score in the middle. So again, I can kind of come in. I can cross numbers off if I want as I'm coming in. And then I find that's my middle number. So in this case, the median in this case, it was 4.5. The median in this case would now be 4. But what you hopefully can see is that if we locate where 4 is, you can see that there are 1, 2, 3 scores below 4 and 1, 2, 3, 4 scores above 4. It's not a precise median. And so that's okay. There are ways to calculate a precise median, but we aren't going to do that in this class. So ours is just simple. If it's an odd number of scores, to find the median, put the scores in order and find the one score in the middle. If it's an even number of scores, put the scores in order and find the two scores in the middle and average them. One thing just as a warning, do not try to find the two middle scores in this set of data. It's an even number, yes, 10, but these scores are not in order. If you found those two middle scores, that would be those two. But those aren't in order yet, and so your median is not 3.5. Okay, so just be careful for that. So that was mainly what came up in terms of a lot of the questions, was just the being able to go back and forth between graphs and tables and interpreting the graphs and tables and so on, and doing the calculations. The only other thing somebody had asked has to do with the smooth curves when we do graphs of frequency distributions for populations. So it was towards the end of chapter 2, and a smooth curve, what they're referring to is something like a normal distribution, where we get a distribution of scores that looks something like this. That smooths the curves. Now, we know that when we're working with populations, we often have relative frequencies on the y-axis. Technically, there would be a y-axis here. So these are relative frequencies, not actual frequencies. So when we had this over here, this F, those are actual frequencies. Actually 1, 2. There's 2 3s, there's 2 4s, there's 2 5s, and so on. So we have actual frequencies here. But when we're working with populations, we haven't actually measured everybody. It's more of a theoretical distribution. And so again, we use relative frequencies for the height. And then partly because of that, we also smooth out the curves. And what they mean by smoothing out the curves is basically this is what this distribution might look like if we did it as a histogram. Okay. So it might look something like that. But we just, instead of having that jagged edge, we just smooth it out. And so that's partly just to let us know that this is a population. We don't know the actual frequencies. And so as a result, we just have a general sense of where people are scoring. And what this really simply tells us is that, again, height is how many people right here around the mean. So let's say these were IQ scores. IQ scores have a mean of 100 and a standard deviation of 15. So most people, a lot of people, high frequency over here, have scores right near 100, 105, 95, etc. Very, very few people have scores up here or down here, because it's noticed that the height of this curve is very low frequency. So these are scores like around 130 or higher, or 70 or lower. So that's kind of the idea in terms of why we use that. It's not a huge deal. In this class, you're just going to see these curves, especially when we get to basically chapter 6, we'll start seeing it, because we'll start talking about the normal distribution, which is this bell-shaped curve. And it's a curve, it's a smooth curve, and it's partly because we're working with populations where we're not working with the actual data where we have the true absolute frequencies. We're just using relative frequencies. The last thing that I remember that somebody had a question about has to do with a little bit it's often people ask, or get a little confused on what graph to use when. And the main thing there in terms of the graphs is you want to use the frequency distributions, the histograms and the frequency polygons for interval or ratio data. But if you have only nominal or interval scale, then you want to use the bar graphs. We put a gap between the bars to indicate that these categories down here are not part of a number line, whereas this is a number line. So when we're working with frequency of interval or ratio data, we can. The scores are actually equal intervals apart. So IQ scores are equal intervals apart. So it's truly an interval scale. It is not a ratio scale, because they're 0 IQ doesn't mean the absence of IQ. It just means you got all the questions wrong. It doesn't mean you don't have any intelligence. But when it comes to ordinal or ratio data, we have to separate the gap here between these bars is an indication that this is not a number line. So we don't even know if we're going up in value here. They're just at least, probably because it could be nominal, that these are just categories. It also could be these are categories where they go up in order, but again, the distance between each of these categories is not equal intervals. Okay, so that's most of what I saw with the questions that were related more to chapter 2, our frequency distributions. And then when it comes to the measures of center, the main thing, really, most people seem pretty comfortable with that. I think a lot of people had calculated means before, averages. We talked already about how to calculate a median. And so that was another question that had come up was, I get a little confused on how to calculate medians. So notice that we're kind of combining tables and measures of center on some questions. But the thing that most people then struggled with was one is just which score do I use when? And the answer there is basically use the mean when you can. So the mean is our best measure of center. So use the mean when you can. And mostly when you can means you can calculate it. So sometimes we don't have numerical information because we're working with a nominal or ordinal scale, and so we can't calculate a mean. But there are also a couple situations where you should not use the mean, and that's with when you have extreme scores in your group, or you have a skewed distribution. And that's where the scores tend to be more on one side or the other. So you have a lot of people who have low scores and a few people have higher scores. That would be a positive skew. Or you have a lot of people with high scores and a few people with low scores. That would be a negative skew. When you have that, don't use the mean. The mean is going to be a problem there, because one of the benefits of the mean is that it measures, its calculation is based on everyone's score. The problem is then if you have an extreme score or you have a tail from a skewed distribution, that pulls the mean over and kind of moves it farther away from the middle. And we're, again, trying to measure the center because we're trying to measure the typical or average score. And the mean usually provides that, except in these situations. And so that's where instead it's better to use the median. Okay, so if you haven't watched those videos, definitely watch my videos on, well, any of you should always be watching the videos for this class. So that's the main thing in terms of when to use them. Basically, you're going to try to use the mean when you can. In these situations, you can't, so you're going to use the median. And then anytime else, like basically we sometimes use the mode, but that's really for nominal scales. You can't even do a median there. Otherwise, the median can kind of replace most options. Okay, the last thing, and this tends to be the biggest question from chapter 3, is there's a couple, 2-3 questions on the problem set that people struggle with, and they're what I refer to as algebra questions because you're solving for different parts of the formula. So let's for now, let's use the sample mean formula. It's the same as the population mean formula, it's just the symbols are slightly changed. So again, mean is always sum of x over n. So when it's a sample, it's a lowercase n and a lowercase x technically, but I'm not always consistent with that. So, okay, so let's say I know that's my formula for the mean. So most questions then would ask you, okay, what's the mean for this set of scores? Or it might even tell you, so you know how many scores there are and then you can add them up. So that's a pretty straightforward, that's a pretty straightforward kind of question. But sometimes it's often really helpful to help you deepen your understanding of our formulas is to not just ask you questions that do exactly what we taught you, but to ask you questions that you have all the tools to answer the question, but you haven't seen this question before. What that requires is a deeper understanding of the information, and what you're finding is you're trying to connect what you know to the question. This is a very important skill, especially more and more today. As computers are going to take over what we can do when we just follow rules like recipes and just follow anything that can be converted to an algorithm, computers are probably going to do a better job than most humans. So where humans can stand out is finding connections, being able to apply things in ways that weren't already programmed. And so that's where having these skills is going to be incredibly important for you, and also will partly help your success, because you'll be that person who can find the answers to problems that are new and people are struggling with, because the typical way we approached it doesn't work anymore, and you'll then be able to see how to apply things that you know to it. So for instance, one of the questions comes up with is, just let's say we've got a group of scores. You have an n of 9 and a mean of 6, and it's basically what is the sum of x. Okay. Well, that's not a normal question. I didn't necessarily teach you how to do that. But when you see that, you have a formula. This is a tool that you can use. And what's kind of interesting is if you understand it, it has 3 components here. It has a mean, a sum of x, and an n. And you'll notice that those 3 things are here. And so you can just plug these in, and you'll have a part that we're looking for as the only thing that's not filled in. So we do that, and it says, okay, the mean is 6, and the n is 9, and what we don't know is sum of x. Okay, but thankfully that's what we're looking for. So now I just have to use algebra to get rid of the 9 here. To do that, I multiply that side by 9. Those 9s will cancel out. When I do that to one side, I have to do it to the other side as well. And so we get a sum of x of 54. So all the scores add up to 54, right? And part of why that's helpful is because it might start helping you understand what sum of x is. Rather than just a symbol, it has meaning. And what it is just adding up everybody's score. So sometimes doing these things where we're solving for different parts can be really helpful in terms of really forcing you to understand what each component means. Okay, now this is where it then goes up a level. In the next one, it essentially says, okay, we've got an n of 9, a mean of 6, same as before. But we're going to add a score that has an x. It's a score of 5. So we're going to add one more person to our group, and they have a score of 5. What's the new mean? All right. So this was our original one. And then another question on the problem set looks more like this. So again, we already did part of this. So that was part of the setup in the problem set is okay, well, some of this you've already done. But again, you can start with this, okay, so we're looking for a new mean, but I have a mean already, I have an n, and if I'm not really sure what to do, again, I can do what I did up here before, and I find that my sum of x is 54, okay? Now, here's where it helps to know what the symbols mean. So instead of just saying, oh, that's a sum of x of 54, but this is an x, and it wants a new mean, I don't know what any of that means. If you understand that this means sum of x, add up everybody's score. So when we add up all 9 of the people's scores, they add up to 54, right? And then we add a person with a score of 5. And we want to find out the new mean for this group of people. Well, again, to find a mean, we know we're going to use the formula sum of x over n. And I can now figure out the sum of x and the n from everything I have here. What I can figure out is the n because it was 9 people and I just added one more score. So now my n is 10. I also can figure out the sum of x because now that I've calculated what the sum of x had to be originally, I can say, all right, the 9 people originally had a sum of x, add up all their scores, and it added up to 54. So for this new mean, it's going to be that all of those 9 people's scores added up, 54, plus the new person's score. And that then gives me 59 over 10, or a 5.9. So we knew the sum of x was there, and then now we know the new mean, if you added this one score, is a 5.9. So you can see how, one, you're doing a little bit of what we did before, which is simply just taking formulas, a tool, and applying it to what you're given to try to find something that's missing. And even if you didn't know to look for the sum of x, if you just did this and you said, oh, okay, well now I've got the sum of x, and then you can see this here, you say, okay, that's also a sum of x, but why wouldn't it then just be a mean of 6 again for the new mean? Well, because we added a new score, and if this is sum of x, and this is where you have to realize, add up everyone's x, that's just for the 9 people. But now we've got an extra x. And so it's going to have to be that 54 plus that extra x. So these were all 9 x's plus the one extra one adds up now to 59. And again, because we added that one, our n went from 9 to 10. So to answer this question, you need to know what all the symbols mean and not just have it memorized and not know what it actually is about. So that's where, again, we're sort of transferring our knowledge. This is very important. And then the last one takes it to another level, which is, again, is kind of hard. But we start with, all right, we've got a group of scores with us 5 people, and it has a mean of 8. Okay, so 5 people have a mean of 8. So that means these people average an 8. So some are going to probably be above 8, some are probably going to be below 8. And we're going to remove a score. Okay, and the new mean, after removing this one score, the new mean is 7. Okay, so the original mean we're going to indicate with the subscript. So this was the original mean sub 1, and then the new mean is a mean sub 7. And we removed one score in between here. Okay, so that's the setup. And the question is, what is the score that we removed? And so what's this score equal to? So to do this, again, what I can do is start with, okay, this first group, even if you're not quite sure to do, again, just find a formula that has those components minus 1. Plus an extra component. So again, that's our mean formula, sum of x over n. We have the mean, 8. We have the n, 5. What we don't have is the sum of x for this original group of 5 people. So again, we solve by multiplying both sides by 5, and we get the sum of x is 40. Okay? So all 5 scores has a mean of 8, and that's because all of the 5 scores add up to 40. But we're going to remove one score from this group of x's. All these x's add up to, that's what sum of x means, adds up to 40. So we're going to remove a score, and now the mean's 7. Okay, well, again, I'm not really sure what to do. What I do know, though, is it has a mean of 7, and I can, again, maybe to try to help me, say, okay, well, mean equals sum of x over n. What can I do with this? All right, so I know the mean is 7. I know the original sum of x is 40, so it's going to be 40 minus something, but I'm not sure that's going to help me. Do I know my n? Well, the n originally was 5, and I removed one person, or one score. So now my n's 4. Okay, so now I know that. So let's go ahead and solve for sum of x and just see how it goes. And so we multiply both sides by 4. So we get 28 is the sum of x. Okay, so what that tells me is that when we had all 5 scores, all of those scores add up to 40. When we removed one, now we only have 4 scores, they add up to 28. Well, how does that happen? Well, I took a score out. What score would I have to take out of this to get to this? Well, that's just 40 minus 28, or 12. Okay, so if I take the 12 out of here, I now have a sum of x of 28, and then that mean would now be 28 divided by the n of 4, or 7. Okay, so that was the score that was removed. Again, I partly understand it only if I understand all of the symbols and what they mean. So I suggest that you keep a tally of symbols on a sheet of paper, what their definitions are. But then I also suggest that you try to understand not just the definition as a set of words, but understand the meaning of that definition. Okay, so this was a little bit longer. This is 40 minutes. So this is the money point for chapters 2 and 3, and I'm hoping I'll get a chapter 4 one out too. Chapter 5 I might not be able to get to because I'm not sure how many people will have answered or completed the money point by the time you have the exam. So that one, if I get enough questions, I'll put something together. But otherwise, it's not particularly difficult a section. But so we'll see. All right. So good luck.